Welcome back, my dear students, to my channel Civil Knowledge. So today we will solve some of the problems on law of parallelogram of forces. Okay, so we will continue our syllabus. So the problems on parallelogram forces. Okay, parallelogram law of forces. See, if the resultant of two forces P and 1.5 is root 3P. 1 minute. Okay, the resultant if the resultant of two forces P and 1.5 is root 3P, find the angle between the forces. What will be the angle made by the resultant with the P? See, what is the question? So two forces are there and the resultant also given. See, with what I did know, so consider this as P and this is Q. So two forces are there, P and Q. Okay, this is P and this is Q. Q value is what? 1.5 P value is same P. Okay, and they have also calculated the resultant. So R is equal to what? Root 3 P. Okay, what we need to find here? We need to find the angle between the forces. We need to find this angle and also this angle. Correct? Let us consider this as alpha and this angle as theta. Okay, 1 minute. Erase this. So I'll consider this angle as alpha and this is as theta. So we need to find the value of alpha and we need to find the value of theta. So we know that the formula that we derived from last session, that is, what is the formula? The famous formula r square, or you can take as r is equal to, okay, root of, what is that? P square plus Q square, okay, plus 2PQ cos, okay. So which angle you need to produce? Okay, alpha, right? 2PQ cos alpha. This is the formula. And again for the theta we need another formula. What is the theta? Theta is equal to, yes, Q sin alpha divided by P plus Q cos alpha. Correct? So these are the formulas which we derived in our last session. So now what we need to do, using that formula, we need to find what? This alpha we need to find and we need to find this theta. So procedure for that I will show you now. So, so whatever the formula you know, first write that. Okay. See, from the parallelogram law of forces, here P is equal to P and Q is equal to 1.5 P. Okay, and we know the formula, that is R square is equal to P square plus Q square plus 2PQ cos alpha. Correct? Now what we do, we will substitute the value of R square. What is R square? It is root 3P whole square, right? R is root 3P. R square means 3P whole square plus P square is equal to what? P only. Q square is equal to what? 1.5P. Then plus 2P into 1.5P into cos alpha. See, root 3P whole square is equal to P square plus 1.5P whole square plus 2P into 1.5 into cos alpha. Correct? Just I substituted the given forces in the formula. Now simplified. So 3P square. So root 3 square is 3. P square is equal to, you add this both. So 1.5 plus P square, it will become what? 1.5 is 3.25 P square, okay, plus 2 into 1.5 it is 3P square cos alpha. So when we simplify, we will get 3P square is equal to 3.25 P square plus 3P square cos alpha. Fine. Now see, 3P square cos alpha. So 3P square cos alpha is equal to, so we will simplify that. That is equal to minus 0.25 P square. Okay, then again when we simplify, we will get the value of what? Cos alpha. There cos alpha is equal to minus 0.25 p square divided by 3p square. This p square cancels. 0.25 divided by 3, we will get cos alpha is equal to minus 0.253. So alpha is equal to what? Cos inverse of the value. Cos inverse of what? 0.253. Okay, cos inverse of, so alpha will be equal to 94.78 degree. Okay, this is the value of alpha. You can easily solve with the help of the calci. Okay, so alpha is equal to 94.78 degree. Now what we need to find? We need to find this theta value. So for that theta value, what is the formula? So we know that the angle theta, okay, angle theta is made by the resultant r with the angle p. So this is the value of theta. Now we have to find the value of theta by using the equation what? Tan theta is equal to q sin alpha is equal to q sin alpha divided by p plus q cos alpha. Correct? Now what is that? Q is equal to what? 1.5 p sine 94.78. Okay, and p plus 1.5 p cos 94.78. Correct? So when we simplify that, we are getting the value of tan theta is 1.708. Okay, so once we get this value as tan theta, so what is the theta value? Theta value is nothing but theta is equal to tan inverse of the value of 1.708. Okay, so when we do that simplification, we will get the value of theta as theta is equal to 59.65 degree. See, theta is equal to 59.65 degree. Okay, simple easy problem, easy substitution problem. Such type problems will come from the law of parallelogram of forces. Just you have to remember what? The tan theta, okay, tan theta equation, and also the this r square is equal to it, sorry, so this equation r square is equal to what? P square plus q square plus 2pq cos alpha. You need to remember this formula and also this formula which we did know. Tan theta is equal to q sin alpha plus p plus q cos alpha. Okay, so theta is equal to 59.65 degree. So that is the value of theta. Fine. So now we will solve another example. See, two forces act at an angle of 120 degrees. So here they are directly giving the angle. Two forces act at an angle of 120 degree. The bigger force is 50 Newton and the resultant is perpendicular to the smaller force. So one condition is given, the resultant force is perpendicular to the smaller force. Find the magnitude of the smaller force. See here, two forces act an angle 120 degree. So this is what? 120 degree. Okay, the bigger force is 50 Newton. Okay, and the resultant is, they have given the value of r is perpendicular to the, this r is perpendicular to the smaller force. Which is the smaller force? So one is p, means this one is the smaller force. So this is what they are telling us, that it is 90 degree, because they are telling it as perpendicular, right? So when this is 90 degree and this is 120 degree, the remaining angle is what? This angle, this is nothing but what? 30 degree. So 30 degree plus 90 degree is 120 degree. Find the magnitude of the smaller force. We have to find the magnitude of the smaller force, that is OB we need to find. Okay, simple. So we will solve. So from the figure shows the parallelogram of forces acting. Let P and Q be the forces acting. So P is 50 degree, 50 Newton, and Q maybe we need to find. Okay, so OA is equal to P, that is 50 Newton. OB is equal to Q, we need to find, and OC, see this OC is equal to what? That is R. Okay, I'll write again. See, OA is equal to P, OB is equal to Q and OC is equal to R. So this full angle is what? 120 degree. Okay, and this is what? 90 degree according to the condition. So remaining angle is your 30 degree. Okay, now by given, so we'll write the given, that is angle BOA. Angle BOA is what? 120 degree. It is given. I am not finding anything, right? So resultant is perpendicular to the smaller force. According to this condition, angle BOC is 90 degree. Okay, this is also given according to the condition. Okay, next what we can do, see the figure here. What is that? This is 120 degree, this is 90 degree. So I explained you how this is 90 degree and this is what? Your 30 degree. So angle made by the resultant with force P. So R with the resultant P force is what? 30 degree. Okay, this is 30 degree. Correct? So this is what? The angle is theta. And this is alpha is what? 90 degree. Okay, so what we need to find the magnitude of the smaller force. We need to find the value of Q, right? So see, from the relation, that is tan theta is equal to Q sin alpha plus divided by P plus Q cos alpha, we are getting what? Tan 30 degree. So this is 30 degree, right? Tan 30 degree is equal to Q sin 120 divided by, so alpha is what? 120 degree. So also alpha is full degree, sorry, it is 120 degree. So alpha value is full, this angle is alpha. Okay, now so angle made by the resultant with force P, alpha, that theta is 30 degree, alpha is 120 degree, right? So tan theta is equal to Q sin 120 divided by 50 plus Q cos 120 degree. So when we simplify, tan 30 is 0.577 is equal to Q sin 120 degree. So sin 120 is 8.66 Q divided by 50 plus Q, remained it cos 120 degree, 120 is minus 50. Okay, so is equal to 0.866 Q divided by 50 minus 0.5 Q. When we further simplify, we will get 28.85 minus 0.289 Q is equal to 0.866 Q. So 1.55 Q, 1.155 Q is equal to 28.85 Q. So the value of the smaller force magnitude is 24.98 Newton when we simplify. So simple basic mathematics, when we apply the law of the basic mathematics, we are getting the value of Q is 24.98 Newton. So this is how we solve the problems of any two forces, and including the resultant. Either they ask to find the alpha value or theta value, or they will give one value P and they will ask Q, or they will give the value of Q and R, they will ask to find the value of P, like this. Same, what we need to remember, we need to remember the formula, that is tan theta is equal to Q sin alpha divided by P plus Q cos alpha, where alpha is the angle between the two forces A and B. Whatever the forces they give, no, the angle between them is the angle between them is alpha, and the angle between the resultant and one of the forces is what? Theta. Fine. Next, Polygon law of forces. So what is this Polygon law of forces? If a number of forces acting simultaneously on a particle, okay, if a number of forces, if two forces are there, we will surely use what? Parallelogram law of forces. If more than two, okay, if number of forces are acting simultaneously on a particle, be represented in magnitude and direction by the sides of the polygon, taken in order. We should taken in order. Their resultant may be represented in magnitude and direction by the closing side of the polygon, taken in the opposite order. Okay, so what they are telling means, see here, P1, P2, P3, P4, P5. So 5 forces are acting on a particle, that is O. Okay, so according to the definition, what is, if a number of forces are acting simultaneously on a particle, yes, it is acting, may be represented along magnitude and direction, then it should be taken in an order. Then the resultant of all these force may be calculated, or may be the calculated as the closing side of the polygon in magnitude and direction taken in opposite order. So I'll show you. See, I'll take in order. See, the P1 is the force, right? So I'll take the force P1. Okay, this is the P1, this is head of the P1, and this is the initial stage. So it is P1. Now P2 is next force. So P2, how it should be taken? See the orientation, same way we have to take the orientation like this. This is what? P2. Okay, its head is here and tail is on the head of P1. Next what? Another force is P3. So P3, how it is? It is orientation is like this. So P3 we should take like this. So P3. Okay, then P4 is what? It is downwards like this. So P4 is taken as like this. Wait, so this is P4. Okay, then what? Another force is there, P5. So P5. Okay, all the forces I took as I taken in order, that is head, tail, head, tail, head, tail, head, tail, head. P5 is head and tail is on the P4. Now its resultant, we need to find resultant, right? Its resultant is given by the closing side of the polygon. Okay, this is the green color is the closing side of this polygon. This should be closed now. If I connect this, it is closed. Now this is what? The closing side of the polygon taken in the opposite order. Here the arrow changes. Okay, see in this diagram, P1C, P2, P3, P4 and P5. So this is the closing side, that is R. So the resultant value is given by this closing side of the polygon. So in the parallelogram law of forces, the diagonal of the parallelogram would give the resultant value. Here in the polygon law of forces, the polygon, the closing side of the polygon will give the resultant value of the forces, right? See. So figure shows the number of forces P1, P2, P3, P4, P5 acting simultaneously at a point B represented along the sides of a polygon taken in order as AB. So it should be taken in order, that is AB, BC, CD, D and EF. Okay, and the resultant R is given by the closing side taken in the opposite direction, that is AF. So this is given by, this is to AF is given as what? The resultant of all these forces. So this is the law of parallelogram law of polygon law of forces. Okay, so I'll show you the statement once again. So if a number of forces acting simultaneously, okay, if a number of forces are acting simultaneously on a particle, be represented in magnitude and direction by the sides of the polygon taken in order, okay, their resultant may be represented, it should be taken in order, then their resultant may be represented in magnitude and direction by the closing side of the polygon taken in opposite order. See, taken in opposite order, that is AF. I hope you understood the how we solve the polygon law of forces, right? So here I conclude this topic for today's session.